Hey everybody, this is Larry. This is let's see, day 13 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I'm probably gonna do an extra bonus question if this thing if this thing loads. Good old Leetcode. Yeah, so definitely hit the subscribe button, and if you feel today's problem is too easy, then let's do an extra one. It may be a premium though, so you could watch me do an extra one in any case. But yeah, wow, our thing's not loading at all. Do 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 do. Sorry, friends. That is the problem with recording it live, I suppose. Things sometimes, technology. How does it work? Uh, hmm. Did it load? Nope. Do I have to click on it again? Oh, there you go. Let's not look. Okay. Today is a hard problem, but it seems like I've done it before, even recently. Maybe that I have to, not cheat and look at it. But okay. Oh, it's 2246. So I think maybe it's just a contest problem that we've done. Maybe not that recently, but at some point. So let's take a look. The 2246 longest path with different adjacent characters. So you're given a tree rooted at node 0, consists of n nodes, okay. Each node 0 is the root, okay. Okay, that makes sense. So basically we have a tree, a rooted tree. So instead of giving us an edge list, we're given this parent list to represent the tree, and we have to find the longest path in the tree such that no pair of adjacent nodes on the path have the same character assigned to them. Okay. Okay. I mean, I think I understand it. Let's see. Let's take a look at an example just in case, because I feel like I've been misreading a lot, honestly. 013 is ABC, and then otherwise is AI. Okay. So, I mean, I think... To be honest, it doesn't seem that impossible. I think now another way that I can think about it is that because we only care about adjacent nodes, node path and adjacent nodes. What we can do is create a new forest being a group of trees where we just disconnect the graph on those edges, right? Meaning that here from 0 to 2, we just disconnect that thing, but then we make sure that we do a recursion on 2, for example, and then we do the same for 4 and so forth. The only other thing that we have to make sure, and this kind of depends on how you implement it, because if you implement it in a generic way, which I intend to do, then it doesn't really matter. In a sense that, like, if you start at 5, you have to make sure that you go up the tree instead of, versus like you start at 2, which is the root of a new tree, right? Okay. And then, of course, once you kind of have a forest, then you just take the max out of all the longest path in a tree, which I believe is an easy problem, or maybe medium. I don't remember. Leetcode's rating and grading, it changes all the time anyway. But it is a problem that if you're working on tree problems, it is something that I definitely recommend you do in general, and also just because it is something that I think is doable by most people with some practice, or maybe not could be doable, just that it is probably on an interview level, right? As in that's the expectation that you probably have. So then this particular problem becomes decomposing this problem into that problem, right? So yeah, okay. So said a lot of stuff. We can still probably do a tree structure, but instead I am going to oops. A lot of random stuff popped up on my computer, so that's why I got a little distracted. Check something real quick. It's awkward, but okay. Yeah. I had to click on some X's because it's just blocking my screen. Just tell me that I haven't backed up my computer in a while, which is true, so maybe I should back it up. But okay. Anyway, so yeah, parent. Oh wait, no, that's not how we will structure it. It's so it's the we in enumerate parent. So where v is the parent, right? Kind of. Yeah. And then if p is equal to -1, we continue, which we just skip this. I mean, I don't know. This seems a little bit unnecessary, but and of course, because after that, it doesn't matter what the root is, right? It's just that that's the structure that we're given. I think this is okay. I just want to make sure that this is 0 index. Seems like a 0 index. Yeah. And then now after we have this adjacency list, then yeah, then we have like we said, the two things we can have to do. One is just writing the longest path rooted at or something like this, and then it's just the current node. And then if I'm so used to writing if node is none, but obviously this is an index. So yeah, and then basic and this of course also parent, so you don't go up the tree. And then for child in adjacency list of node, if child is not going up the tree, then we do the longest path rooted at child. And in this case, unlike I think the Leetcode one is a binary tree, so you can kind of do some math on the left right. But here, the longest path is just keeping track of the two. Basically, you know, you think about if there are two things you can return, right? Let me actually think about this for a second. But basically, instead of a binary tree where you know it's a if this node, if this current node is in the path for the longest path, then it's just the left path plus the right path, right? But of course, now that we have many children, I think, yeah, it doesn't have to be a binary tree. Oh yeah, it doesn't have to be a binary tree. That's why they do it on a parent list. Then you just take two of them, right? And in a greedy way, of course, you take the two children with the longest path, and then that'll give you, well, and in that you actually return the depth of it. So yeah, so here maybe we return to, a tuple where you have the depth and the longest path so far, right? And in theory, you can also do it with a global variable for this one, but yeah. Okay, so then now we have to keep track of the, and you could write this in a couple of ways, maybe even with 2-element heap or something like this if you really want. But yeah, maybe like I have just something like longest is equal to this, and then longest append this thing, right? And then if longest, if length of longest is greater than or equals to 3, if longest of, I'm just doing like a bubble sort basically. If the second element is bigger than, oh man, this is a little bit awkward. All right, I'm just going to make this return the depth, and then just use the global one for the longest, because it just makes the code slightly easier. I don't know if I advocate that, but I don't know. That's happening, and I'm sticking to it. But you can also do it in 2 depth first search or traversals or retrieve you like. But yeah, so okay, so longest is longest 1, and you can write this in a for loop, but I'm not going to. 1 is equal to longest 2, or maybe we just swap them. Right, and then if longest of 1 is greater than longest of 0, then again we swap them, right? And you know, sometimes you see me just like writing random looking code, and it's true because these things, there are no like strict patterns about it. Just, you know, do whatever you feel makes sense, as long as you know as long as long as you get the algorithm in your head and you know what you want to do, you know, the code is just an expression of that code. So, you know, people always think about patterns and all these things. I don't know. I think this one is a little bit wrong though. And length of longest is yeah, and then I could do something like this. No, that's not right. I don't know. I think this one I'm not quite sure about, to be honest. And also I have to do it the other way, otherwise it just gives me an index error. But Yeah, remember, friends, in programming, you're getting paid to solve new problems, not, just write out patterns. Anyone can do that. And apparently, with Chat GPT, maybe, even more, anyone can do that. But anyway, yeah, it should be okay. I think this is just going to do nothing anyway. If whatever. And then, yeah, if length of longest is greater than you, I guess I could just put it. No, yeah, whatever then. Something like that, right? And then now we just return longest of 0, maybe even sum of longest plus 1. That's just the two longest path, and then plus 1. So, oh wait, no, I messed this up, to be honest. So basically, let's just say we have a root thing that's just like the best thing, and then in this case, I kind of conflated them. I messed up, my fault. But yeah, but basically this is the sum of the path, but we're not returning it. We're just going to update this. The sum of the longest two paths, or up to two paths, right? Because you can also just have one path or even 0 path. I wonder if sum of 0 elements, maybe we have to do like default is equal to 0 or something like that. But yeah. And then what we return is actually max of longest plus 1, right? Also maybe default is equal to 0. Don't know if that does anything. I think that it does though. But yeah. So one more thing is that, of course, if we do it naively, like if for I in range of n, also I messed this up. I kind of skipped some stuff with respect to this S thing, so I have to go back and fix this. I meant to put it here, but I forgot. Sorry, friends, I am very a little bit jumpy today. My code is jumping around because I keep on forgetting stuff. Okay, so here, let's just say if S of U is equal to S of P, then we continue, because then we're not drawing the adjacency list. That's all we have to do, actually. It's not that bad, but I thought I said it, but then well, I mean, I don't know. I don't know if I said it or not, but definitely did not program it. So yeah, and then here, and that's all you need to do, which is actually kind of crazy, right? Because I did so much other stuff. But yeah, and then here, you can do something like longest path rooted at I, and of course, and then return best at the end. So this is going to work, but it's going to be n squared, just to be clear. Maybe I forgot about the parent part. Yeah, so this is going to work, but it's going to be n squared. Oh, jeez. Oh, I forgot this part. No. Why did it like that? Default isn't okay. I never remember if default needs or something. So this is going to work, but again, this is going to take too long, because this is n squared. Because for each node we might visit multiple times, which is the number of times number of nodes are in that subtree. So we just have to kind of keep one more thing, which is a scene array. Basically, it just prevents us from doing the same connected tree, the same tree in a forest more than once. So yeah, so scene of node is equal to true, and that's all you need, really. And then of course here, if not scene of I, yeah. All right, let's give it a submit. Hopefully I didn't have a silly typo or something. It worked for the inputs, which is good enough for me. Did have a time limit exceeded. What did I do on April 16? 10-18 day streak. Yeah, 69%. How did I do last time? About the same. Did I do it the same way? Kind of did it the same way with more if statements, and I guess this was during the contest, so I did sorting because I was lazy or something. How did I get time limited? This seems like a very silly time limited. Seems like I don't set the scene on the children, which is see, which is very sad. I'm sad for the past Larry. But yeah, so what is the complexity here, right? Well, there's there are n minus 1 edges, as this is a tree, so there's going to be n minus 1 edges, and we even remove some edges. But at the core, this is linear time, linear space, right? Because, well, linear space you could see here and maybe here for the adjacency list. But also for this one, each node will only be called once. So it is going to be linear time, linear space. Just a regular traversal of a tree. It's just that it is not binary. And I do urge that. I think someone mentioned it the other day, maybe a long time ago. Probably Josh, I think, because he complains about it sometimes. Where some trees, at least in Leetcode and maybe other places in the beginning, there are a lot of focuses on binary tree, but trees or binary trees are not the only type of trees. There are other type of, or they're just trees that might have more than 2 children, right? So definitely, a lot of the stuff that you learn with pre-order, in order, all that stuff still applies to regular trees, but you just have to sometimes reconceptualize what you learned and think about, okay, now this works for two children. How do we extend it, right? And what does it look like when we extend it? Yeah. And this is what you get. So yeah, still linear time, linear space, and that's pretty much what I have. I'm going to do a bonus extra question because I want to get some mileage out of my premium subscription. So yeah. That's what I have for today, though. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.